Welcome to another video on my Raspberry Pi running Raspberry and Linux, programmed in Python, connected to a serial port, network cable and band cable, as well as a Raspberry Pi camera, right here supported by a fischertechnik stand, with a probe to the oscilloscope for showing the serial signal. Connected to breadboard with some electronics and fischertechnik, and primarily this part of the board. MCP 3008 analog to digital conversion using the SPI serial peripheral interface protocol of 4 wires with 3 probes for the main signals. Fischertechnik light dependent resistor, ordinary light dependent resistor, and negative temperature coefficient resistor. Last time I managed to finally get the datalog nicely, although something is not quite right yet. So let's go to software and see how things work out. Software side, which means that this is the virtual network computing with the Pi scope, with also a terminal to start the software, this one, code, camera to observe what is happening here, also the Raspberry Cam view with a few seconds delay, and oscilloscope. Right now it is showing here the datalog. Let's name the tab, and this is showing the serial connection. I have to quit this connection because of Octave, and last time what I did was correcting this line and this line and here and here. It had a D instead of a C, so everything was published as a number instead of the character. Bytes versus ASCII, American Standard Code for Information Interchange. But and let's immediately quit this. No. Why does this go wrong? This is correct. And in here are missing LDR2 and the resistor. Also to compare this signal with serial peripheral interface lines and serial interface versus the Pi scope. Anyway, let's start by running everything. Run this one and run the script, and oh, of course, no, not this. I need just a tab, and claim ownership of in this case it is 1. That should work. I suggest that it goes. This shows nice. It will also show nice in Minicom, but this is the purpose. Let's also view this one, because I would like to see this signal also here. And the point is that you see the serial line coming very frequently, but nothing here. So I don't like that. And right now this signal is showing very shortly, but I want that signal. And this signal is at 200-400 milliseconds. And now I am at 500 milliseconds on the oscilloscope. And now at 1 second I see here signals. Let's try half a second. And this is now what's happening. So now I finally see both protocols, both SPI and serial, although details are nowhere. So now how does this respond? How does this end up? So can I already find anything with the data log? Well, first I have to find if the timing is good, and right now it's not good at all. It has 4 seconds, now 5 minutes difference, so it's not being written to at all. Although this is running very nicely. Can I also see that here? Yes, of course I can. And the second LED that is located here is not visible for the camera, but it is visible for me right here. And now you see my finger appear. So this is the LED next to that one. And I have to really show it like this. So changing some value. And let's see how the LED responds, if they do, because it should respond to LDR1. It doesn't respond, so I'm covering up this one. It still goes on. The LEDs should respond when the value is higher than 100. So far, there's no response. So that's a bit weird. Anyway, let's check for timing. Still nothing. Okay, let's then stop this. And now it suddenly has been updated. Time to check. Okay, now LDR1 resistor and NTC are in place. But why is that happening? Why all this? I want it nicely and cleanly. Yeah, okay, new line. Oh, can I verify that? So I have, let's say, NTC, or more or easier, LDR2. Okay, or LDR1 for what I care about. Nice number, by the way. So it has LDR1, then a space, then the number, then a new line. Yeah. And then what? Why is this doing it? What's the L, N, N, L, R, N, and here nothing? It's a bit strange. But at least now I know that it's working completely. And that is what it is about. Also, once again, oscilloscope. If I compare this to this signaling, it's not exactly the same. This is with actually at 1 millisecond, let's say that one. 1 millisecond. And this is also not quite correct. So I'm not quite sure what to think of it. Does it matter? Not that much, but I'd like to have some nice signaling. So what's the difference between Pi scope and a real oscilloscope in value? They should be the same, kind of. And another view on the Mac website, well, not the Mac website, but the Mac side of the VMC viewer with VLC cam, and more importantly this one, because how is this combined with the other one? And if I look at both, this seems to be in delay, but they should be the same. And then I am referring to the one on the Linux desktop laptop. And I can also show on the Android, but that's even different. So which is which? I don't know. What's the added value of the Mac? Showing that This can be viewed anywhere within the same network, of course, and multiple instances needed to show on different VNCs, virtual network computing instances. It takes a lot of power on a not so strong Raspberry Pi 1. Nice to see. And yeah, this is all on the Mac, of course. Let's see if this works the same when I put my finger on it. And yes, that is, I have to move it to grab it. And data won't be different. Data on the Pi scope. But what I do not get is the blinking on the LED, because if I look at the software, then it is really made for only blink when it is, I think, higher than 100. And I have to check that. So a little pause in talking. And yeah, if the LDR1 is higher than 100, then the LEDs go blinking. But when is it higher than 100? That's the point. Anyway. And a final interesting idea is using the tablet is, can I run this program at the same time twice? That's something I haven't done yet. So let's try this and press enter. Channel already in use, but it runs anyway. And then you can see, yes, I am now running it twice. And does it have the same values? What is running when? And it seems to be a quite nice thing. Yeah. So I can run it at 2 times, like I can run PiScope twice. So I could have shown this on the Mac as well. The only thing is, I haven't yet been able to cancel this running a program on Android, because I need a Ctrl+C or something to quit this, and pressing Ctrl+C on Android, that's a bit tricky. I haven't managed that yet. So the only thing I can do to stop this is pressing or closing this terminal. But this is an interesting idea, running everything like this. And of course, let me turn the camera a bit. It's all on that as well as on that. So yeah, it slows everything down because it's a single core device. But apart from that, yeah, nice. And I think with fixing this last time, it's been a nice experience. And by the way, look at that second LED, which is flickering a bit, quite different than the other one. So this one is flickering a bit and that isn't, although they are the same LEDs and they're flickering at the same time because they are wired through. So yeah, nice and interesting. And with this I say thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment or suggestion. I very appreciate that. You can also follow me via Instagram and Twitter. And please show your appreciation by making a donation via either PayPal or Wired. You can also become a patron and by means of a pledge may have your name mentioned on my website and with my videos. More information on donating, patronage and visiting my website, please see under this video, as well as for my Twitter and Instagram. Not sure if this experiment with the Raspberry Pi is going to be continued. But have a nice day. Take care and bye bye.